Yeah. So we can start now, sir. Yeah. YouTube is set.
Okay. Good evening, all. Uh, Back to the next session about the agentic AI application. Uh, there were some queries regarding the before going to the agentic frameworks like LangChain, or sorry, LangGraph or Crew or AutoGen. Uh, First, let us know about how to make the agent. So I would like to quickly tell you about that. I'm sharing my screen. Just let me know if it is visible or not. I hope my screen is visible.
Yes, sir. It's visible. Yeah. We can see.
So, uh, yeah, I will tell you when to start with the VS Code. Just be patient and listen to the conversation one more time, right? And then we can start with the uh, VS Code. So yesterday I shown you one workflow for agentic AI chatbot and Gen AI chatbot. Now, if I talk about agent, then agent is nothing but having the three capability. First is if I show you the yesterday's workflow only. So in that particular workflow, we have three components. You can see clearly that this is called as AI agent, right? Now it has having the three capabilities, two capabilities, or probably three for a time being. First is the brain. This is your brain. This is a memory, and this is a tool. Now, if you have these three things into the picture, then you can call this entity as an agent, AI agent, right? Now, LangGraph, LangChain, these are the orchestrators which are used for making this kind of agent through coding framework, where we are going to append these models. We are going to use certain tools inside the agent, and we are also going to append the memory so that we can make one AI agent, right? So these are the frameworks will help you out so that you can just integrate the models inside the AI agent which you are going to make. You can integrate the memory and you can integrate the tool. Till you don't have these three components, you cannot call it as an agent, right? So the question was that can we learn about making some agents before going to the LangGraph or LangChain or Crew AI? The answer is that these are the frameworks which helps you to integrate this whole picture, right? If you don't have this picture, till that you cannot call it as the complete AI agent which does the job of agentic AI applications. Okay, so that's why I will start with first the difference between the LangChain and the LangGraph, which is the concept which I will discuss. Meanwhile, in between, so can you tell me what is the first principle, which means from pure Python? So that's what I am telling you, dear Girish. The thing is that you have to first append the model, then you have to integrate the memory, and then you have to integrate the tool. This whole thing will be done in Python using LangChain or LangGraph libraries. Libraries are the frameworks. Oh, so can you just unmute yourself, and or maybe you can write it down, the chat in chat what you are trying to convey, so that I can also know. Yeah, can you? Okay, I'll unmute. Or can anybody unmute this participant?
Hey, hi, Nicholas.
Girish, you can ask your
Yes,
question.
yes, yes.
We
Hey,
have
hi,
made
Nicholas.
you panelist
And
now. Yeah.
uh,
Yeah, go ahead.
yeah,
Yes.
yeah. So I was talking about, so see, LangGraph and LangChain is going to add you lots of the abstractions. The pure agents that you are the component that we have said, right? With annotator. Annotator is again more abstractions, right? Just to illustrate that what is the agent can be. But as a academic point of view, first we should build a pure agent from the Python. Remember, when we learn deep learning, right? Before learning Keras and PyTorch, we did everything in NumPy, isn't it?
Go ahead. Yes, I'm listening.
So in same way, before going to LangGraph or CrewAI or even LangChain, we should build to learn the complete agent into the Python, pure Python.
Sir, I am talking about that only. Just see to this code. See, is it IPython notebook? Are you able to see this extension?
Yes.
This is the Python notebook. Okay, right? Now, what I told you that if you want to see how you can make an agent, that you have to understand it very clearly. Agent means it should be having the capability of model. How you can integrate the model? Can you tell me without any framework how you can integrate the model? Forget about no code platform.
Okay,
Can you tell me?
you
If
see,
you know anything, you can tell me.
you can have the
Hmm.
LLM from anywhere, right? You can
So
have the, let's say,
okay,
Open API LLM you are going to
yeah,
take,
So just
right?
look at over here. Okay, let's go point by point. Okay. Now see, this is the LangChain. Are you
Mhm.
able to see? I have installed the LangChain pip
Why
install
LangChain? Why
LangChain.
not direct only OpenAI? That is what I'm saying. LangChain is again an abstraction.
Sir, just I wanted to tell you that LangChain is the platform which actually integrate all the model inside it. Chat OpenAI, Claude, Gemini, Olama, which is installed locally, Grok, Mistral, Cohere, Azure, AWS Bedrock, Hugging Face, Together AI, Fireworks AI, everything.
Sir, you are right in other way, but what I need, I want that you should refer the course from Andrew AI, Agentic AI, Andrew and Mackenzie AI from Deep Learning AI.
Sir,
So
here
don't get
we are working
confounded on
on
that.
agentic
So
AI application.
my idea is that I have given the clear analogy that like before going to the PyTorch and Keras, I hope you are coming from that era only. And we have built things into the NumPy. Every neural network we have built in NumPy, isn't it? So we can build the a pure agent in pure Python only.
Sir,
So
if
leave that, please. Please proceed.
the thing is that all the concept which I discussed yesterday, I don't want to migrate my flow from whatever we are discussing, whatever the frameworks which we have, Crew, LangChain, LangGraph. Every framework is supporting how to make an application. I don't want to go to the proprietary options where I can only use OpenAI Playground. And in OpenAI Playground, I show you how to make an agent.
No,
Right?
again, why we are going to open a playground? No, no need to do just if you want to don't put a proprietary, right? You take Olama and then use this local LLM to do this.
That's what I'm
There is an
telling
option.
you. That's what
So
I'm
my
telling
idea
you.
was that only Python, pure Python. Like again, analogy is the same. Let's you proceed. It's again going to be endless discussion.
Yeah.
We are not on
Okay.
the same
Thank you.
page.
Yeah. Okay. Thank you. So, so the thing is that let's discuss about the framework only. That this particular automation or this particular flow where we have a AI agent, we have a chat models, and we have a tool. All these things you can integrate through only one of the framework, and that's why we are studying only frameworks. We are not studying the individual part. That is why human in the loop, MCP servers, RAG, all these things are possible with the help of frameworks only. And that is why we are learning this unanimous platform where we can integrate all the things one by one, right? So let's start the discussion about the LangChain and LangGraph. So why directly LangGraph? I'll just keep it in the slideshow. So why LangGraph? Why not LangChain? Now, when we talk about LangChain is a sequence. It helps you to implement the things in sequence, right? You have some blocks. Supposedly, if I'm having this block where I will. This is the block where I'm making one workflow where I'm making one block generator. I want to generate a block, right? Now that block generation is possible through different AI agents. So supposedly this is the agent which help you to research. This is the agent which help you to write. And this is the agent which help you to evaluate the block. Right? So researcher, it is having a task of research. It is like a team where we have a team of the employees which does the specific job, right? So researcher, the job of researcher to only research. We have given the prompting like that. We are asking the agent like that go on to the Google APIs, hit those APIs and search about the specific particular person, specific about particular topic. Let's say what is AI, which we have already discussed yesterday. Okay, so that is the researcher part. Then next is the writer. Once all the research will be done, the output is given to the input is given to the writer. Now what is the job of writer? Writer will write the content based on the outline or maybe the whole context given by the researcher. Okay, and the writer will write the block and then that block will be evaluated by the evaluator agent. That is one more agent which we discussed yesterday, that there is a supervisor, there is a evaluator. Okay, so that evaluator will evaluate your particular whole block. Is it correct? Is it proper profession? It is a professional looking block. Is it a decent looking block, right? Is there any text heavy words are required to be integrated? Okay, so this is the chain. One by one, the workflow will get triggered by giving the input. It will do certain task. This will do certain task, and this will do certain task, and it will generate the output. The output is nothing but the block which we want to publish it on, let's say on LinkedIn or maybe a Medium or maybe any other blog social media platform where we want to publish that blog. Okay. Now this whole workflow is in chain, in a sequence, right? There is no breaking of the sequence. And that is why we call it as a lang chain. We call it as a lang chain. Why lang chain? Because it follows the sequence in a series, right? There is no break of the flow, and the flow is not going back to some of the agent which will maybe do certain tasks. Okay, there is no looping, there is no conditional branching, there is no parallelism, there is no dynamic looping, there is no dynamic condition integration, right? There is no human in the loop, right? So in that case, when the workflow is very much simple, what we can do is we can go for something called as LangChain. Okay, so this is how the LangChain will work. That is what is the fund of LangChain. Whereas if I talk about the LangGraph, what is LangGraph? LangGraph is nothing but where you can make your whole workflow in terms of graph. You can just formulate your workflow in terms of graph. Now you know how graph looks like. Graph is having some nodes. That nodes will be having certain kind of edges which directs them towards some kind of different nodes, right? And then if any point of time, if the looping is required, then we can directly go to that part where we want to repeat that workflow, or we want to begin again because there was not satisfied output which I got from the AI. So in the same case of block generation, supposedly the evaluator is evaluating the block and it found that the block is not proper, it has to be revised. Then what can be done is the evaluator will redirect that flow towards either researcher or towards the writer, wherever it is requiring some kind of nourishment or polishing. Okay, so that's where LangGraph will come into the picture, will help you to formulate the graph. The whole workflow will look like a graph. So you can treat that workflow as a graph, right? So whenever you have simple workflow like this, you can always go for LangChain. Again, LangChain is not the uh, it's not the LangGraph is not the replacement of LangChain, I should say. LangGraph is the encapsulation. You cannot go further without LangChain. LangChain is required in each and every case. I'll show you how to integrate LangChain also wherever it is required. So that will be the discussion when I will show you some codes where also I need the help of LangChain. Yeah, you cannot bypass the LangChain. LangChain is the required library, which was the first framework where you can integrate all the models. So LangChain is required wherever. I'll show you the part where we will initialize or import the libraries wherever we require. So that's where the LangChain is helpful. Okay. So this is the LangChain preferred workflow. Prompts, you give the prompts, you have LLMs, you have something called as retrievers. Retrievers means those who will be getting the answer from somewhere through APIs, through any external knowledge base, and then you have a parser, right? So parser, I will discuss in somewhat more detail that what are these parsers. Okay. So but when we talk about line graph, yesterday I discussed with you one example of HR recruitment or backend engineer recruitment. Okay, in that case, what was happening is that there the flow was getting migrated again and again. Okay, so like the agent will make a JD, that JD will be posted on LinkedIn, then it will wait for some days, let's say 7 days wait is there. Okay, but if there are no satisfactory applications are received in the count, maybe number of count is very less, supposedly it is less than 20, then the JD has to get some kind of relaxation. So for that we added that full stack criteria, we added that it should be can be a remote job, not in personal job. So this is kind of a looping where we have to do some kind of revision. And in that case, LangGraph will always help us. Same way in creation of JD, when the JD is not perfectly made by the AI, then also we require some kind of human approval. Okay. So after this, if you have a scheduling of the interview, that will be done. Conducting the interview, sending the calendar invite, that also required the human intervention. And then onboard and offering part where you give the offer letter through agent and onboard that particular employee. So that all thing requires some kind of conditional looping or branching, conditional routing or routing. Conditional routing means what? That based on the condition, the flow will get routed. Okay. So supposedly if I talk about JD part, then after creation of JD, whether we should put it on LinkedIn or we can go for internal referrals. There are two paths which we have. So the conditional routing is what? It is based on some condition, you make a decision that which path to get select. And when it will put that JD on the LinkedIn, it has to wait for some time. Let's say 10 days waiting time, buffer time. It has to wait for getting the appropriate application. That is also not very much encouraged in the LangChain. LangChain is maybe it may not be that much perfect in that part where it has to stop the workflow for some time and then restart the workflow or resume the workflow from where it was stopped. in that case also lang graph is very much helpful and effective. Okay, so this is how the code wise differences which are there in langchain and langgraph. So it is kind of a if else loop. When I talk about langchain, it is all about if and else. It works with this kind of logic. Whereas in langgraph, it is having the flow diversion. It can be waiting for some time. The workflow can be paused for some time, right? And at the same time, it can implement or resume the workflow whenever it requires. Now, how it is able to do that? It is having something called a state. So I will discuss this also in much more detail. Now, when I talk about LangChain, it is stateless. Stateless means what? That if I if I don't include the memory, right? So what will happen is that it will not be able to remember the long-term context. Okay, so if I talk about, let's say, RNN LSTM, RNN is having a problem of vanishing gradient. It is not able to remember the long context. So that is why we introduced the LSTM, which is having two things. One is short-term memory, one is long-term memory, one is the input gate, one is the forget gate. So whatever is to be required to be remembered, we are able to remember, put it inside the long-term memory, which whatever is the current thing, we will put it inside the short-term memory, which are the required thing, which are the not required thing, we can directly forget using forget gate. So that is what is the concept. So same way, this line is stateless, and it is using uh, some kind of format to remember the thing, which is a short-term memory. Right, in that case it is about dictionary. It is using some kind of dictionary. So I'll discuss this also in very much detail, that what is this dictionary. Okay, the dictionary is like a key and value, which you know about in Python, that it uses this dictionary format, that supposedly JD has been posted, and the post, it is waiting for 10 days, so the status is pending, and how much applications are received, 5 applications. So it is able to remember this through dictionary. So it is using this dictionary format. Once it is using this dictionary format, it is having some drawbacks in terms of remembering the part, right? So that is where we don't use LangChain. Whenever we require some kind of memory, long-term context, then we always go for the LangGraph. Okay. Now, in LangGraph, how it is able to do that? Okay, so there are two things inside this. One is typedict and the other is pydantic. Now, how it is able to do that? Again, I will explain you in more detail once I will start the LangGraph core concepts. Right. So it is taking the things in terms of states. Now, what do you mean by states? States means again one kind of context, a memory context. And that context is written with the help of typedict or pydantic, specifically typedict. Okay, those who are from computer science, they may be knowing this, but yeah, I will be telling you why typedict, what is typedict in again detail in the introductory discussion using code only. Okay, so in LangGraph, what is happening is, supposedly this is the node A, which is the first node. It is having some context inside some state. Okay, so let's say context of uh, adding two numbers A and B. A equal to 2, B equal to 3. So the state will be having two numbers. A is a key, B is a value, 2 and 3. But instead of calling it as a dictionary, we are calling it as a state itself. And that is why it is stateful, not the stateless, as the LangGraph or LangChain is. Okay. Next is LangChain is synchronous. Now, what do you mean by synchronous and asynchronous? Synchronous means that it cannot wait for that 7 days, or maybe somewhere down the line, the loop will get break because it is using if else logic. It is not using the state. It is using some kind of static rule for doing all these tasks. Okay. So it follows that chain. And whenever we ask to break that chain for some days, it may goes fail in that case. Okay. So that is vulnerable. LangChain is vulnerable in some cases, and that is why the LangGraph is preferred. So whenever you have this kind of thing, human in the loop or maybe waiting part, where you have to break the chain for some time, then in that case, it may go wrong and it may not be able to remember the state from where it has to resume one more time after certain amount of days. Okay, so that is why it is a stateless and it is asynchronous. Okay, so those are the two terms that you can call it in the side by side. That is, it is a synchronous and it is a stateless. Asynchronous. Now, what do you mean by asynchronous? Asynchronous means what? It can pause also for some time. Okay. Now, how it will be able to remember the state? Because it is using some kind of persistence. It is using some kinds of persistence, and that persistence is nothing but checkpointers, right? So what you can do is that when you make a graph, supposedly this is your graph, then this is a flow of your graph. Okay. Now, at every node before starting and after the node, we have something called as checkpointers. Now, what do you mean by checkpointers? Checkpointers means these are the checkpointers where it will be storing the states itself. So what was the condition before the addition? Supposedly I want to add A plus B. So before the addition, what is the condition? Okay, so A is 2, B is 3. It will store that. The check pointer will store that. Then it will go to the next node. Once it will come over here, this node is, let's say, adding the two numbers. Right? So there is one more check pointer kept over here after this node. So what that check pointer will store? That A plus B is already done, and the answer is 2 plus 3 equal to 5. Okay, so that is the functionality or maybe the different facilities which are being offered by the LangGraph. Okay, so that is why it is asynchronous, and almost all the frameworks which are there, which has come after the LangGraph, like Autogen is there, uh, Crew AI is there, they are giving you the functionality of async. If you get the chance to learn about Crew AI or maybe uh, Autogen, then you can just search about or learn about this async function, right? Okay, what is async? That you will be get to know from that. Okay, then this is we need to add. I'll show you. There is something called as in-memory saver in LangGraph, right? That is the check pointer which you need to add. Initially, this is how you can do to start the persistence concept or start implementing the persistent concept. So once we make the graph, I'll tell you that how to do this in memory saver, okay, or checkpointer or maybe persistence part. Now fault tolerance. Now, if supposedly this is my workflow, and obviously I told you that this should be in a sequence part. Okay, there's a series of the blocks events which we have kept. There is a researcher, there is a writer, there is a evaluator, and so on. Okay. Now, supposedly, all these agents are having two things: memory, tool, and model, which I already shown you. So, tool is what? Tool is nothing but any API call. Let's say it is an API. It is calling some kind of API. Let's say in yesterday's discussion, I showed you about make my trip. So if I ask my agent to book a ticket from 17th May to 29th May, I want to go to Delhi or maybe Goa, right? So it will hit this make my trip API. Now it may happen that this API goes down or API is not working due to maintenance in the server where the application is hosted. In that case, what will happen is that in that case, the LangChain is not able to tolerate that downtime because API is not working. It is not able to retry. It is not able to apply retry logic because it is a simple sequence chaining workflow. Okay, and maybe it is not able to give you the proper output. Okay, so anything goes wrong in between dynamically, in that case, LangChain will be failing, and that is why it is very fragile. It is not having the capability of tolerating the fault. At the same time, LangGraph. If I talk about LangGraph, yeah, it is used in thread program. So when I talk about LangGraph, in LangGraph, what is happening is that whenever there is a stop, or maybe whenever there is a break in between, right? Or whenever there is a human intervention is required. In that case, LangGraph is offering you the functionality that you will be able to pause for some time. If the APIs are not working, it will be try to halt for a time and then again retry it out. And at the same time, it is able to remember the state also. Okay. And once it resumes the workflow, let's say there is the API downtime or API timeout. After that, once it will apply hit to the API, get the output, and also it is able to remember the state because it is a stateful. It is not the stateless. Okay. So that is why this is a LangGraph which is more robust in terms of if I talk about fault. If you want to understand that async part, it is very easy. Supposedly, let's clear it right now only. There are two functions which I have written. Suppose there is one function for making a tea, and I am writing async before that. Async making a tea. There is one more function called as async making a coffee. Okay. Now what I want is that any one of them, if it is getting completed, then the output I should get. Right. Supposedly, and the tea has been made earlier compared to coffee, or maybe coffee is made earlier than the tea. Supposedly, the coffee is ready, that function is implemented, the code is implemented. It should be able to give me output directly without waiting for tea to get completed. And that is where LangChain fails. LangChain is a sequencing workflow. Sequencing workflow means what? That until and unless this complete, this cannot come. And that many times what we have is we have a parallelization. In parallelization task, we require that the output should be immediate as and when that particular task is getting completed. Okay, so in parallel workflow, LangChain may become miserably fail. At the same time, LangGraph will help you a lot because it is having a async functionality. So async is very much easier concept that is why it is used in that thread programming or multi-purpose threading or whatsoever parallel programmings are there, right? So that is that part. And once you talk about LangGraph, then you can have multiple subgraphs also. You can have multiple workflows inside one workflow. Okay, right. So that is why LangGraph is that much popular when we talk about compared to the LangChain. Second, the next part is observability and debugging. Now in LangGraph, as I told you that it is having the persistence idea. Persistent means you can save the states. It is a stateful. You can monitor the state using observing the history of the state, right? So it is persistent, and that's why it is more observable compared to the LangChain. Okay, so for that we use something called as Langsmith. Okay, Langsmith is the framework like a LangChain or LangGraph. Langsmith is also the part of the debugging, where you can observe your whole workflow, how it is getting implemented at the backend. Okay, so you can track down each and everything. Once this node will start working, it will give the output of this node to this node. So you can see the condition of states in the Langsmith one by one. Okay, right. So that is why LangGraph is more more observable, or maybe you are able to reverse engineer the things very well compared to the LangChain. So this is the final conclusion. Conclusion is that LangChain you cannot replace. Okay, uh, this LangGraph is actually built on top of LangChain. Like you have a TensorFlow and Keras. Keras is built on top of TensorFlow, right? So you just use the TensorFlow through Keras. Same way, LangChain is the part of LangGraph, and you cannot replace LangChain completely, or you can avoid the LangChain completely. You have to use LangChain because this is a basic and foundational part of making an AI agent. LangGraph is specifically for orchestration. Orchestration means making an SOP. Like when you make a SOP means first this task should get completed, then second this task should get achieved, third this task should get achieved. This is called as orchestration. When you have orchestration, you need a LangGraph. But basic foundation is LangChain. So LangChain you have to learn when you start learning about the AI agents, right? Or when you start making a simple AI agent, you should know about LangChain. Okay, right? So this is these are the differences between LangChain and LangGraph. So it's all about sequential chain, whereas here you can have a conditional branching, you have parallel workflows, right? It is a stateless, it is stateful, it is synchronous, it is having async functionality, it is not robust to the fault, it is much more robust to the fault due to the memory context savers and state savers. It is best for simple chatbot, which I shown you yesterday, reactive chatbots. Whatever you ask, it will give you the answer. That's it. But if you want your agent workflow to perform autonomously the task, then in that case, we have to anyhow go to the LangGraph. Okay, right? So this is the basic introduction of LangChain and LangGraph. So now I will directly go to the next part, which is the difference between the core concept of LangGraph. Now, we studied about the LangGraph, that why it is that much important and that much useful. Okay, right? How it is able to do all these things. That is what is the main concept in LangGraph. Okay, so now let's understand about that how it does all these tasks. Okay, right? Now let's look at this diagram. Supposedly you are making one flow. You are making one workflow. Workflow of what? Workflow of any particular application. Any particular application is, let's say, content creation. Content can be anything, right? Blogs or YouTube videos or podcasts. Right now, podcasts are also being generated through AI, right? Any content creation task, which is a very booming industry right now, whenever we talk about AI, then they are following some kind of SOPs, workflows, right? Now, how these workflows are getting implemented node by node, right? So for that, you have to study about basic stuffs. The first is node. This is, let's say, node. Then there is edge. What is this edge? Edge is nothing but giving you the relationship between the two nodes. Now, what do you mean by that? Let's say there is a researcher agent and there is an edge from researcher to writer. Now, what this edge is actually telling you? It tells you that the next task is nothing but writing the blog. Okay. So this edge can be a normal edge or it can be conditional edge. Conditional means if any condition triggers, then that edge will direct your graph to next node. Okay. So supposedly this is a check which we put it inside, let's say, flow chart. This is a check. If the value is less than 20, then it will go to this way. If it is greater than 20, then it will go to this way. Okay, now here we have two different blocks. So based on the condition, the edges will direct the graph. It will help the graph to get executed node by node by providing the relationship between the two nodes. Okay, and that's where we have different kind of workflows also in the line graph. Right. So there are some conditional workflows, there are some sequential workflows, there are some parallel workflows, and there are some looping kind of workflows where you have a feedback. Right. Now this is the example which I kept to understand that what is the first part, which is a state. So as I told you that this is a node which forwards the execution to the next node. Now what it forwards? It forwards the state. It forwards the state. Now what is this state? State is written in something called as type dict. Now what is type dict? So supposedly I will give you the coding example, but first understand with this. Let's say I want to add two numbers, which I give you the example, 5 and 6. Currently there is no result, and this is my one state. Now this state will travel to the next node. This whole state will get travel over here. Now what is the edge from input node to the next node is sum. So what is this edge? Edge is directing the flow of graph, that where it has to go next. Now it will go to the sum node. At that particular node, we have written the functionality for 5 plus 6, which is 11. Right. So now your state is not null. Now the result variable inside the state is being overwritten with 5 plus is equal to 11. So what do you mean by that? That means that state are mutable. The states are mutable. Mutable means every particular node, whichever is there in the line graph, can change the state wherever it requires. Okay, states are not immutable, they are mutable, right? Once it will calculate the result 11, let's say the next node, which is directing from this edge to the next node, which is multiplication node, and where I want to multiply this result with some number, let's say 2. So this job of this node is to multiply the result of previous node answer with 2. So that will get multiplied over here. 11 into 2, that is 22. So now again, my result variable will get overwritten. From 11 will become 22. Okay, right. So that is the feature or importance of state that line graph offers you. Now the question is that how this is being made. So this particular state, we are writing it inside type dict. Right. So I'll show you what is type dict. Just wait for a minute. Then there are some reducers functionality which is offered by the lang graph. Now, what do you mean by reducers? This workflow can be having one problem. The workflow is having one problem. What is that problem? You can directly guess the problem. The problem is that the result variable is getting overwritten every time. Right? Initially it was null. Then it is becoming 11. Then it is becoming 22. Every time result variable in the whole state is getting overwritten. That is good for this workflow or this use case. This use case, it is okay that it has to get overwritten by null to 11, 11 to 22. That's what we require. That is our requirement. Okay. But many of the tasks in which we have to preserve these answers. Okay, because what happens is that we cannot have one variable of storing the answer. We have multiple variables for storing the answer. Okay, in this example, if you consider that supposedly I want to preserve this variable for also division, let's say 11 by 2. This is multiplication by 2, but the same answer should be having 11 by 2. And at last, both should get store the answer somewhere over here. Now, what it will store? 22 or 11 by 2? 22 is multiplication result. 11 by 2, which is 2.5. Right? So in that case, uh, what will happen is this division result will be nothing but that 5.2 will be reflected over here. Over here, it is nothing but 22. Then result has to store both of them because we have these two nodes. Okay, right. So in that case, what will happen is that this result variable will get conflict. Either it can store 22 or it can store 11 by 2. So what it has to store? Okay, so in that case, what will happen is that there will be a confliction. So what we want both the answers. And for that, we are using reducers. Reducer is what? That it will be nothing but, okay. Reducers are what? Reducers are nothing but the entity which will help you to get the answer for one variable at a time, but it will also do this task, which is called as merge. Merge means what? That let's say result is 22 and second result is 5.2 or 2.4, 3.4, 4.5, whatever you take, any number. Multiplication, division, any operation. Okay. Now, what will happen is this 22 will get stored first in this state, and at the same time, the other answer which you will be able to store, which is the next answer through something called as merge operation. Okay, and who will provide this functionality? The functionality will be provided by reducers. So reducers are the entity which helps you to not override the answer, but it will help you to store the answer so that whatever answer you require for the next task, you will be able to get from this reducer list, which is the answer variable. We will declare it with the reducers. Okay, right. So that is how it is able to help us when we have the more number of answers for one variable itself. Okay. Now, how this whole process is getting executed. So I'll explain you in very easiest way. Let's say I'll open one, or I'll write it over here only so that you can get the idea. Supposedly, this is a node. This is the next node. Then we have two parallel nodes. Then we have one more node over here, one more node over here. And then both the answers are getting merged over here, and you will get the final answer over here. Let's say this is your workflow. Okay, we will see the workflow, how it looks like. Okay, now what are these nodes? We are telling these are nodes, nodes, nodes. These are edges, edges, edges. What are these nodes? Each node is nothing but one Python function. Each node is having one, it is nothing but it is a one Python function or one task which is being implemented through one Python function. This node is also one Python function. This node is also one Python function. This node is also one Python function, and so on. And the edges will direct your function answer to the next node. So how you are going to get the answer? Once this node is executed, means this Python function is executed, then the answer will be stored inside nothing but state, which we already see. It will store inside the state. Okay, So supposedly 2 plus 3 equal to 5. The answer will be stored inside the state. Now 2 plus 3 equal to 5. How we have done this? Through some kind of Python function. We have written one Python function of def add, and then we pass two numbers a comma b. Def add, and then we pass the two function a comma b. So what will happen in this case is your the output of one node will go to the next node, and the message passing is done through state. Okay, so message 1 state, message 2 state, message 3 state, and so on. Okay, so this is how the whole things are getting executed. So it's very simple to understand. Node is nothing but making a graph, the collection of nodes. One node, one Python function. There is an edge for the next node. Again, there is one more Python function which is doing some dedicated task. Edges are giving you relationship. It may be conditional, it may be traditional. Okay, and the message passing from one node to the next node is done through something called a state. These are the things that you need to remember when you play with line graphs. Okay, right. Now this line graph is actually inspired by something called as Google Prickle, which is graph based processing framework. So just go on, you can just search it on that what is Google Prickle, how it does the processing. Okay, so just find out that how it works, and the inspiration of line graph is through Google Prickle on. Okay, so what we need to do first is, what is the first step? First, make a node one by one, then connect those nodes through edges. Each node is nothing but one Python function which does some job, gives you the answer in terms of state. The state is written using type dict. I will again tell you what is type dict, and that's how it will be able to execute the whole flow. So you have to first make a graph, connect the edges, you have to compile the graph. Compile means that you have to check, is there any breakpoints in the graph? Is there any failure in the graph? Are the nodes are connected properly? For that, the routine procedure what we do in the language is also compilation. And once you do the compilation, you can go for a execution part. Okay, so that's how the whole process goes on. So you can see to this particular workflow that how it does the job. Okay, there is initial state. Okay, the initial state, the output of this going to the next node, that is nothing but message passing. It can go to the several branches. Either it could be a sequential branch, it could be a multiple branches. Okay, so the edge can forward that output to this node. This is again one Python function. It can forward the output to this node. This is also one Python function, and both of the answer will get compiled, and it will give you the final answer. So here we need to know about these things: what is state, what is reducer, how it passes the message through the states, and what are these edges, how it is giving you the relationship between the nodes, and how to write this Python function. I hope that many of you are knowing about that, how to write the Python function, the simple def keyword. Okay. Now let's see how these, what kind of workflows the line graph can perform. Right. So the first workflow is prompt chaining. Prompt chaining means what? Sequential workflow, which was already executed by the LangChain. LangChain is able to do this very well. Okay, so here I have taken one workflow for report generation. Okay, so what will happen is you give the topic, or maybe you can take a block generation workflow only. Take a topic, generate the outline of the block through one of the agent one, which will generate the outline. Then it will check for the, let's say we have put some kind of constraints that the output of outline should not be greater than 500 words, 5000 words. If it is greater than 5000 words, we will reject, and again your workflow will get migrated to generate the outline. If it is less than 5,000 words, which suffice our condition, it will go to the node 2. And there is one more agent 2, which will draft a report, and then you will get the output. Okay. So for explaining this, I have explained, I have kept it in this workflow so that you can understand the overall procedure side by side. Okay. So this is a block generation workflow. So here we are going to write down some message, right? That message is nothing but what kind of objective we want to achieve through all these agents. There are three agents: researcher, writer, and there is one more agent which is nothing but evaluator, reviewer. Okay. So there is one more agent which is a reviewer, which you can see it over here. This is a reviewer, this is a writer, this is a researcher. What I am doing is I am trying to and I'll be giving the input. That input will be traveled to researcher. Researcher will research about topic. Okay, what kind of topic I am giving. For that, it will require some kind of tool help. So I am using some kind of tool. If it is requiring, then it will use. Otherwise, it will not use. It is autonomous. That is why. Or if only chat models are enough to give the answer, it will not go to the tool calling. It will directly use this chat model. And then it will go to the writer. Writer will write the blog, and then it will go to the reviewer. For each of the agent, I have written some kind of prompt. Let's say this agent is having, you are expert in outlining the writer. Your job is to generate the structure outline for a blog post with selection titles, section titles, and key points. Okay. This writer is having some prompt, which is nothing but you are an expert blog writer, evaluator. Revise this outline and ensure it covers the following key criteria: engaging introduction, clear section breakdown, logical flow, and conclusion with the key takeaways. And the last is reviewer. So here reviewer is having some instructions given that you are an expert blog writer. Generate a detailed blog post using the title outline. So this is again the reviewer task is to evaluate. So that thing uh, is nothing but here revised outline. So it's a simple prompting you can do. Okay, I just give a simple prompt so that just to make you understand. That's it. I have not written the prompt with much more care, just to help you to understand what is prompt chaining. This is a prompt chaining workflow where you have everything in sequence. Okay. Now, suppose if I write over here in chat window that what is AI, right? So now researcher will start doing the task. If it is requiring the tool help, it will take, otherwise it will not take. It will run that part, it will do the research for you. Or if it is having the things inside in its own, that is the chat model is again, it's a brain. So it is clever enough to find out the information on AI. So it does not maybe requiring the tool calling. It does this for some time, then it will go to the writer. Researcher has done its job, it will go to the writer. Writer has done his job, it will go to the reviewer or editor. And at last, it will give you the answer. Okay. So this is called as prompt chaining, where it will do all this task with the help of brain, with the help of tool, and with the help of memory. Memory, although I have not attached over here, but yes, this is the prompt chaining workflow. So it is doing many heavy lifting for reviewing the task, and maybe it gives you the output over here. So this is how it does, like AI in plain English, and this is the whole blog it has generated. Okay, this is called as prompt chaining. This is this workflow. Then next is routing or routing, whatever you call. Now, what is routing? Routing means that the user will give you the prompt, or user will give the query to the LLM. Now, router is having the capability to divert the objective to any one of the agent. Supposedly, if I tell you about, I am running one educational AI based course, training course, okay, where I teach to the students or professionals about AI in live classes. Okay, so this is a whole kind of educational startup I am running. Now, I will receive the mail regarding, let's say, who has purchased my co. I will get the information about that in sales agent. It will give me that what is the today's selling, uh, uh, how many customers has purchased my course. Okay, so that will be through my sales agent. Then if I want to know about what is the technicality of my course, or what are the technical doubts maybe appearing, maybe coming from the students or professionals, that I am having this doubt, this API is not working, how to integrate this model. So that query will come to this agent, which is technical agent. And the third is, let's say, somebody wants to opt out from the course and it wants the refund. Then that query will be solved by this agent, refund agent. So the router is nothing but the clever agent which will help the workflow to migrate to the specific agent based on the condition and the task which is being assigned by the user to this particular clever LLM. Okay. So if you want to understand this particular workflow, then you can see to uh, this particular workflow which I have made, so that you can understand how it works. So if I just zoom it out, see, I have made this workflow for, I am having this workflow which is implemented in my backend also, which I used to tackle with my Gmail, because I am also doing some kind of AI consultancy. I receive the mail from the clients, right? So this is my Gmail, which is having some kind of the mail are received in Gmail, which is a Gmail trigger I have kept. Like whenever any email comes to my Gmail inbox, this node will get triggered. So it will continuously monitor my whole workflow, the whole Gmail box, every minute or 2 minutes. This trigger I can just schedule it over here. Let's say at every minute it will check my inbox, that whether any mail is received or not. So this is a Gmail node which I have kept. Okay. Now there is one block which is kind of an AI agent itself. This is an email classifier. So in anytime you will get many inbuilt AI agent like text summarizer, right? Or maybe sentiment. In paid version, it is there, sentiment analysis. These are already available inbuilt blocks which are already there. Okay. So this email classifier will, what it is doing for me is that whenever my email is related to doubt, then it will directly classify that into the doubt category, and then it will forward that query of doubt to the AI agent, and AI agent will solve that query. Okay. So because I have given some kind of functionality to do AI agent. Then the next is, supposedly if the mail is really regarding to some kind of promotion. Let's say I promote my courses, I promote my online courses, or promote my firm for consultancy. Then that email I am having inside this promotion, and that query will go to the this AI agent, which will be helping with this promotional queries from the customers, or maybe from my team itself. Then technical assistance. If any technical assistance is needed, then also I can use this and connect this to this AI agent and get the things done. Then if the mail is related to any kind of updates or any simple OTPs like changing the passwords, so I'll get the OTP on my email. So that kind of classification will go over here, and that will be tackled by this AI agent. And at the last, I can have some Telegram also, which I can integrate so that uh, I will get the answer in this Telegram also. Okay. So yeah, Outlook, Gmail, there is one webmail client, and that is the another is the application client. Okay, so you can integrate Outlook also. Okay, you can integrate Gmail also, but here I guess Outlook, um, yeah, it is there. It is there. Okay, you can use it as a tool. So you can just append this tool with the AI agent, and you can use Microsoft Outlook also. Right, many of the functionality will come in the paid version, okay, of Anytel. But if you are a beginner, then you can just try it out like this. Okay, so this is a workflow which is called as routing workflow. Okay, then next is parallelization. Now parallelization means what? That if I am having one, supposedly here I have taken one example, that there is one video which I have created. Now this video I want to upload it to the YouTube. Okay. Now YouTube will perform several checks on top of my video, because there are some policies of the YouTube that YouTube will not allow you to publish your video directly onto their platform, because there are many false information may be getting passed onto the YouTube. If I do something like that, then YouTube will not allow me to put my video onto their platform. Okay, so there are some community guidelines that YouTube will check, which are the community guidelines by the YouTube. So it will try to check, is there any violation of community guidelines in my video? If there is any kind of misinformation is there, if there is any kind of adult content is there, it will perform several checks on top of my video. Now this task is very it's a task where we don't require some kind of sequencing or conditioning. It is a parallel task. One agent will do the check of community guideline, one agent will do the check of misinformation, one agent will do the check of adult content. And then both all these will get combined, and at last the verdict will come from the YouTube that yes, if all things goes right, you are allowed to publish your video onto the YouTube platform. Okay, uh, I have made one workflow for checking the phishing URLs. I'll show to that, that if the URL is proper or not. Is it a phishing URL, or it is a legitimate URL? So I have made some agents. That agents will check for that link, that if that link is proper link, if it is a phishing link, or it's a legitimate link. Okay, so that is a parallel workflow. Okay. Then next is orchestrator workflow. This is very much important. Now, in this, when I talk about parallelization, every particular agent has their job fixed. That this agent will check this agent will check for the misinformation. This will check something else. Okay. But when I talk about orchestration, orchestration is also parallelization. But what is the difference between this workflow and this one? Here, this can be a dynamic check. Supposedly, any query comes to that orchestrator. Let's say the query is that I want to know about the concept of transformers. I want to know about the concept of transformer. Let's say user is writing a prompt that what is transformer. That query will go to this orchestrator. Now this orchestrator, what it will do is it will try to see the query, like what kind of queries. Is it a query related to scientific or scientific technical term? Then it will try to search that concept from maybe Google Scholar. It will try to search that concept from Google Scholar. If I ask who is Virat Kohli, if I ask that this cricketer or celebrity name, that who is that celebrity, then this orchestrator will give that work to Wikipedia. Okay. And if I am asking about that, what are the latest news of the today, or maybe what are the latest news on war, then this orchestrator will dynamically allocate that query to the Google News. So there are many workers are there, many agents with the tools are there. Now dynamic query allocation will be done by orchestrator, right? So that's what it is, like dynamic research assistant. Again, it is similar to parallelization, but it is a dynamic, whereas the previous case everything was fixed. Okay. And the last workflow is uh, evaluator and optimizer workflow. Now, what do you mean by this? Supposedly, the LLM is generating some answer, the AI agent is generating some answer. Okay. Now, that will get evaluated by one more LLM. As I explained you that block generation where the last AI agent was evaluator or reviewer of the block. So that reviewer of the block will review my whole block which is being generated, and it will check for the quality. If it is okay, then it will accept that, else it will reject. So this is a common workflow which we kept always when we are in doubt that whether AI is actually hallucinating, if AI is corrupted or maybe having some vulnerability. So in that case, we put some LLM to judge the LLM. That is called as LLM as a judge. That is also one of the very good concept, how to evaluate your LLM. We talk about LLM is generating the content, but how to evaluate? For that also we have to learn the concepts, which are one of them is LLM as a judge. Just try to go to this concept and search about that how it works. Okay. Same way corrective rags, which we talked about yesterday. Corrective rags. There also we put LLMs to judge the output of the retriever. So that is the concept which will be known to you once the rag will get started by the faculty. Okay. So this is the last workflow which we have. Okay, right. So now what I can do is I can explain you that what is this concept which is called as type dict. Now what is type dict? We'll start discussing about that first, and then I will explain you why we need this. So I will go to maybe suppose I hope you are able to see my screen. I have opened the paint editor. So this is my first block. This is my second block. And this is my third block. Now, why we need type dict, I am explaining you that motivation. Supposedly, this is my first LLM, LLM1 or agent 1, let's say agent 1, whatever you call. Okay. Model is a brain, agent is having a model. So for the time being, you can consider both of them as a simple one block, which is a AI agent. Okay. Right. Now, supposedly the task of this agent, let's say I give the input to this agent that I am giving you one YouTube video. That video language is English. Okay, right. Now, what will happen is I am asking this AI agent to store the information about this YouTube video in terms of some structured output. Okay, so supposedly this LLM, what it will do is, supposedly this LLM is taking out the transcript of the video. Let's go step by step. I am asking this LLM to transcribe this video, generate the transcription of this video and give it to LLM2. Okay, so here what will be my output? This output is nothing but the transcript of my YouTube video. Okay, right. Now that video may be having many technical terms, tech terms. What I'm asking to my LLM2, okay, what I'm asking my LLM2 that you have to search for those tech terms only and give me the output. Supposedly the video is on AI or Gen AI. Video is on Gen AI. Video is on Gen AI. Now, what kind of technical terms it can involve? Lang chain, then model, then prompt, then parsers. All these are tech terms. What I want is, I want this LLM to only give me these terms. So what should I get in the output? Lang chain, model, prompt, or parser. So what is actually objective? Objective is very simple. Based on the YouTube video, the first is transcription is generated. Transcription, it is in terms of text. Now, what is text? Text is always, I should write it over here that sorry. What is text? Text is always what? Text is unstructured output. Unstructured. But what I want this LLM to give me the answer is, this LLM I want to get the answer which is only technical terms. Lang graph, lang chain, model, prompting, parser. What is this? This is only a structured output. Whenever I want to get structured output from the unstructured input, there I need to use something called as how to get this structured output. And in Python, there are many techniques which are available, which helps you to get the structured output. Okay, you can take the example like this also. Supposedly, the same example, if I want to explain you in this way. Suppose this is my LLM. This is having all the data about supposedly let's say customer reviews customer reviews like Amazon or Flipkart. Okay, now these reviews are also in terms of text. Okay, so this I am giving to this my LLM1. Now what I am asking to my LLM2 is that here I want only this output, that let's say name is X and review positive or negative whatsoever is the class, then Y positive or negative. Now what is this? This whole thing is nothing but the structured output. Where I want to store this I want to store in some database, right? So the input was unstructured, but the output that I want is the structured, because I want to store that into some database. That's where I need some mechanism which will convert this unstructured to structured. Okay, and that's where this type dict and pydantic will come into the picture. Type dict or pydantic. Why type dict or pydantic? Because LLM always understands structured language. LLM always understand structured language. So generally in many cases JSON. Okay, JSON is the format. It is always also used in API callings and all. Okay, JSON is the structured format, and we always pass the values between the nodes through always dictionary form. Now in LangChain we were having a dictionary. In LangGraph we don't have a dictionary because dictionary is a stateless, and there may be many overlapping or confliction will be there if your workflow will become, if your workflow is too much complex. Okay, so in that case we have to maintain a state, and that state is written through either typedict or pydantic, right? These two are the library frameworks which helps you to convert your unstructured data into structured data, or unstructured output to structured output. When you have three LLMs in lineup, one LLM has to give the answer to the next LLM, then the communication should be always in structured form. Okay, because LLM will not be able to understand the unstructured form. Even though you give as a prompt, but you know what is happening inside it. Your text is converted into some numbers through embedding, and then whole process gets starts. Right. So whenever we talk about the conversation between the LLMs, it has to be through always structured format. Now, when we don't have the structured format output, we have to convert it into the structured format output. And for that, these are the available options which we have: typedict and pydantic. There are many more options, but currently these are the two popular options which are being used even in the industry deployment part. Okay, right? There are some more features that has been offered by pydantic. Pydantic is superb. Pydantic is much more robust, and it is uh, very much helpful when you are trying to get the answer from LLM. It will help you in validation, data validation, right? So data validation, I'll tell you what is the data validation. Data parsing, obviously parsing is what is our requirement. So we should get the output that is a parsed output. Okay, so data validation, data parsing, for everything we use pydantic. Okay, or maybe typedict. So in LangGraph, your states are being written in typedict. Again, typedict is again simple dictionary only. There is no rocket science in that. You're having a key and the value, right? So if I want to show you how typedict looks like, just understand the concept, don't worry about the code. Right, see this code. I'll give you this code, so you can just uh, you can also run it in your own part. Okay, now this typedict is actually imported through something called as typing, right? So this is a module and this is the submodule. Okay, right? Now you have to import this typedict from typing, and then this is called as object oriented programming. So if you are uh, less familiar with the Python OOPS concept, then you have to study this OOPS concept before starting with the coding part, because it is very much necessary to know about OOPS concept of Python. Okay, I will try to simplify in my workflows, whichever I will tell you that how these classes are being written. Even if you are not aware about the object-oriented programming, you will be able to easily digest for a time being, just to understand. And then when you do from your side, you can just understand in detail how, what is class, what is object, how to do this. Right? I'm talking about those who are unaware about this, the concept, Python OOPS concept. Okay, so what is happening is I have made one class called as person, and that class person is inheriting this typedict. Okay, now inside this class I can pass the variable which I want. Supposedly I want to pass my name, which is having a type of string. I want to pass the age, which is the type of integer. Okay. Now, what will be happening is that I'm making this class, passing this class into this dictionary, and I'm passing the input as name as Nikunj and age as 35. And I'm defining that as a new person. Right. Now, what will happen is that when you print this, you will get name equal to Nikunj, age equal to 35. Now, what is new inside this? As I told you, this is data validation also. Data validation means what? Like you take the scenario that I am having this code. I am working on one of the project and I made this code. Supposedly I left the company tomorrow. Any new coder will come into the picture. Any new developer will join on my behalf, on my place. Now it does not know that what is the type of Nikunj, like what type this Nikunj is having, what type this 35 is. Okay, so if you use simple definitions of the variables, then there may be a confliction when you pass this to the LLMs. Okay, right? And supposedly, if I make this 35 as string also, then also it will be able to give me the output that this 35 is not. It will tell me that this, first of all, this is not the string. This is the integer. Why? Because it is already being defined inside the type dict. So this will give the clear-cut instruction to the new developer that I need to pass age. In the age, I need to pass integer. I don't need to pass the string. Okay. If let supposedly you passed this 35 string, then what will happen? Then it will convert that 35 to directly from string to integer without your any help or without generating any error. That is the functionality offered by Pydantic. Okay, so if you give supposedly by mistake age as 35, which is a integer string, is what I have given you. So typedict will give you that you are going wrong because someone has already defined that the name should be string, age should be integer. And this is called as one state. This is called as one state. The state should get passed like this only in terms of class, having some variables, having some data types, and that you have to define in terms of dictionary. Okay, so many LLMs are actually supporting this bit structured output kind of thing. So I'll show you. So this is one more example. This example, I am using some grok model. Okay, and I have used Llama 3.3. Okay, this is a LangChain library. Just understand the concept. Don't go into the detail of the technicality. I am trying to explain you what is typedict. Okay, so let's say this typedict is imported from the typing. Right now, this is the class which is inheriting the typedict. Now, how it looks like? Yeah, I'll show you the execution, everything. Just understand the concept. So let's say the input which I am giving to this class is that, suppose this is the same example, that I am giving one review, customer review. And review is about Samsung Galaxy S24 Ultra. That's what the customer used to write on Amazon portal. If you have observed in the review part, they are writing the text review, and they also give you the stars, like product stars are given 1, 2, 3, and so on. But we mainly judge on based on the text only. That is what I judge. I used to see the text only. Now, if I have given this kind of review, Amazon people will not manually map that this sentiment is positive or negative. Point number one about the product. Second is, if the product is having any kind of issue, then what is that tech issue, that also I need to identify. Supposedly mobile, if I talk about, then mobile camera is not that much proper, like the resolution is not good. It does not work well when we have a larger distance between the object and the camera, or maybe battery life is battery is not that much long lasting, right? It is getting, I need to repair it, like I need to replace it again and again, right? So the charging is not that much proper. So if those kinds of tech issues are there in the review which has been written by the customer, I also want to fetch that specifically. I don't want to get into the whole review. If something is positive, that is okay for me as a product manufacturer. But if something is negative, I just want to fetch that. And that is all, that is called a structured output, where I am having something called as the tech issue. And here I will be having, let's say, battery problem. So the problem is battery life. That is the only thing I want. That's it. I don't want that Big Bang review. Now, how this is possible from the whole text? Text is unstructured data. I want the structured data. And structured output should be like this, where this is my key. Key is what? Tech issue. And what is the value? Battery life. So I will just focus on battery life now. I may revise the product. Again, I'll put the revised product in the market. Okay. Or maybe in the next version of my mobile, when I launch the new mobile, then in that case, I will take care about this. Okay. So manually, this kind of thing is not possible. If you make an AI agent to do this task, you have to give the functionality of typedict to it, because it is not able to understand without structured output language. Okay, so many LLMs support this structured output. Okay, many LLMs does not support the structured output. So there are different mechanisms. Like if supposedly if I say that OpenAI or ChatGPT or OpenAI, let's say OpenAI. OpenAI supports the structured output, so it is allowing you to use typedict. And one method called as with structured output. I'll show you, which is that this is one with structured output method. With structured output. Okay, right? So how it will do that? Let's understand first that, and then we will discuss next point. So this is my class, which is inheriting the typedict. Now, what kind of thing I want in my output? I want key themes. What are the key themes? Key themes about the review is write down all the key themes discussed in the review in the list. Like what are the key crucial points? Second, summary, brief summary. Okay. Then third, sentiment. Sentiment either positive, either negative. Give me that answer only. And this thing I am writing because I want to help my grok model to understand what I want in my output, or what it has to look for in the review. Let's say I am telling the grok that find out the sentiment of the review and return it in terms of either positive or negative. So this is called as kind of a docstring. This is called as docstring. Docstring means the text which helps the LLM to understand what user wants in the output. Okay. Supposedly, if I talk about pros means what are the pros of the product. So what I'm asking LLM to give the instruction as write down all the pros inside the list. So this variable pros will take down all the positive points. This variable cons will list down all the cons point. And who has written this review? That also I want. So I am making one more declaration about variable called as name. Okay, right. So, and this is obviously inheriting the typedict class. So what you can do now next, your model is grok. You just append this whole class over here, which follows this review. Review is nothing but the class name. Review is nothing but the class name. Okay. So what I'm doing actually, I'm teaching my grok model to follow this when it gives the output. That is what is called as with structured output. Now your model is trained on top of review class, and that review class is talking about that I want the answer in terms of this only. So you're teaching your LLM to give the answer like this, and that is why I'm calling this model as structured model. So when I get the output, I will get the output in terms of structured like this only. Okay. So what I can do is I can run it for you. Right. So I have given all the instruction inside this library GitHub. Okay, my GitHub. So here I have kept one file which is readme file. So I am showing you a step-by-step procedure only so that you can follow that. Okay. So currently I am in this folder, that is starter folder, where I am having this file called as with structured output typedict.py. Okay, right. So what I need to do is I need to first activate the environment. Why environment? Because in my environment, I am having my Grok API key. So environment is nothing but one of the environment file where you will push something which is nothing but your API keys. Your API keys, right? So why API keys are put inside the .env, which is .env environment file? Because when you push this folder onto the GitHub, this environment file will not be pushed because this is having a personal API key. Okay, so if you see starter folder, there is .env file, but when I go to my GitHub, you will not find any .env file, right? Because that is personal property. Okay, so that will not publicly open to the GitHub. Okay, so what I need to do is these env files are installed in the environment. All the requirements file, requirement means all the libraries which I will be using for running my workflow. Whatever libraries you want to take help inside your code. Let's say this code. Here I am using LangChain Grok. It is from ChatGrok. .env, load.env. So from wherever I am importing the module, that must be inserted inside this requirement.txt. Okay, so let's say from .env. So .env is defined over here. LangChain Grok, from which what I am doing is from LangChain Grok, I am actually using ChatGrok. So this is to be defined inside the requirement.txt. LangChain core.a. So you have to install all these libraries first. Okay, inside your virtual environment. You require your whole project is getting executed inside one environment. If you go for a next project, you can create one more virtual environment. If you are targeting, let's say this is a starter folder, then LangGraph chatbot, LangGraph router, all these are having env file. Every project is implemented inside the different virtual environment. Okay, but if I talk about same folder, then in same folder I need to have only one virtual environment inside which I'm able to run all the codes which I have kept over here. Okay, so first you have to activate this virtual environment. How to activate this? I have already given the instruction. So inside this you have to just go to the readme file and activate the virtual environment. How to make the virtual environment, I'll tell you, but I have already created. So this is just a kind of, so my virtual environment is created. It will be getting this kind of thing over here. Okay. Now what I need to do, I need to import these libraries so that whatever code I will run, I don't need to install again and again. For that, the command is pip install -r requirement.txt. That is also written it over here. Just copy and paste. So it will run all the requirement.txt. It will import all the libraries which I have defined inside this. So my environment is ready, my libraries are imported. Now whatever code I will run, these are the support which I have already kept somewhere in some repository, which is called as requirement.txt. It will try to get this because it is already installed in inside the environment. I don't need to import one again and again. Now I can use the functionality inside whatever it offers, like LangGraph is offering to make a graph, LangChain is offering to implement the RAG, LangChain Grok is offering to help you use Grok model, LangChain core is having some functionality. .env is nothing but loading the environment file while I am having this Grok API key. Okay, so I'll tell you how to do this, but for a time being, you just uh, try to understand. This is also inside this, so I have already implemented this requirement.txt. Okay, now if I want to run this file, which is with structured output, so just you need to copy this, or maybe, and you write Python with structured output pydantic dot py. So it will run and give me the output. So since I am running this after a long time, may take some time. But understand the flow, right? I'll show you the output. Just wait for a while. So this is how you can declare that what are the key themes, what is the summary, what is sentiment, what is pros, what is cons. It will give you this output directly. You just have to pass this review to this structured model. And the structure model has already learned that how to give the which structure output from the review class. And review, you have already made it over here. Okay, so this is called as type dict. So we are writing the states in terms of this only. Right? Okay. Okay, so till I get this, I guess it has I can explain you one more workflow till that. I guess I opened after many times. So okay. Yeah, I'll share the link. So the first workflow is nothing but which I explained to you this one. This simple workflow, or maybe that addition of numbers. Yes, this workflow. How to implement this using LangGraph? Now inside this workflow, there is no LLM involved. Yeah, I will tell you the API keys from where to get which kind of API keys, what model I am using. I'll tell you all. Right. So see the output. I will open that one more time. Yeah. What I'm asking, print result, and that inside which I want sentiment only. Right. So here I've written print result sentiment and see what is the output. Positive. Why? Because if you go through the review, I recently upgraded to the Samsung Galaxy S24 Ultra, and I must say it's and the S Pen Igniter, all is this. These are the pros. There is no cons inside it, so it has given me the positive. If you change the literal, or maybe if you change the variable, let's say name. If I change it to name, and then again I will run it. Okay, so it will find out what is the name. It will, so ultimately see the output. It is not the unstructured output, it is the structured output. Okay, right. So see, it has given me the answer, Nikunj Tahil Ramani, which is over here, review by this. It has found from the review itself. Now, how it was possible? Because I have explained this grok model that learn this and give me the output. Okay, right? So I hope this point is clear, that what is type dict and how we are going to proceed with the type dict. Now let's go to the first workflow, which is this workflow. This does not involve any kind of LLM. It's just the addition task, or maybe we are going with very simple first task, which is just to start making a proper flow that you just get into the line graph slowly. Okay, right? So now whenever you want to learn any library, then always go for doc pages. I learned all the concepts through LangGraph, any library, LangChain, LangGraph, whatever you call. I always learn through the libraries, doc pages. Yeah. No, API keys I cannot give you. You have to generate it on your own. I can tell you which kind of API keys you need to keep ready. Like for Grok, you can just go to this Grok Cloud API. I cannot share my own API key because this is personal, right? So here you can make an account and create the API key. Okay. Supposedly, if you have the Chat GPT subscription already there with you, then from the playground you can just import the API key. Okay. Then if you have if you want to go for Gemini, then Google AI Studio. Okay. Here you can just create the API key and copy that API key and put it inside this environment variable like this. Grok API key is equal to this. Okay, right. So I'll tell you which kind of API keys. See, for this whole 10, 12 files, yeah, types of it. That's what I'm telling you. Grok, you model keys, right? This is the model Grok. This is the Hugging Face, right? So you just have to create the API key from this model, go to the API playgrounds and create the API key. I guess no. Kimi K 2.6 not possible. There are certain hacks, but that cannot be publicly disclosed. Okay. So LangGraph, always go to the public this documentation and try to read how to install, how to quick start, right? How to do streaming, fault tolerance, everything which I explained you in the PPT, everything is possible. Just look at the doc pages. Like fault tolerance, how LangGraph is fault tolerant. It will give you the whole code also, like how to implement this. It will give you small modules, but I will tell you in detail that how these whole things can be implemented. But just go through this document. Don't uh, rush to the directly programs. Okay, don't directly jump to the programs. Always read documentation pages and then come to the programming part, because yeah, okay. For the person who is not from the CS background, they can always take the help of even models. Like you can just ask your model to help me to understand about lang graph with simpler details. There is a guided learning also in Claude and ChatGPT. There is an option, there is a plugin, guided learning. I guess there it is in Claude and Gemini also. Guided learning. Use that plugin. Okay. I'm not able to recall where it is. I guess it is in Gemini only. Uh, you can just prompt it, or maybe you can just actively active that plugin of select that plugin of guided learning, and then write down the prompt, help you to understand about language of simple details as like a 5-year kid. So it will tell you the whole Landgraph architecture framework in a simpler way, step by step. Like what should you should learn first, what should you should learn second, and so on. Right. Even if you try to read these pages, then also you will get at least, uh, if you are even a beginner, you can get some idea, because anyhow all these concepts are actually uh, demonstrated using Python code. Okay. So first you should be aware about the Python object oriented programming. Okay, that is the first and foremost requirement. So you have to first understand about the Python OOPS programming, and then you can go for the line graph. So because it is having all the, suppose if I write about LangChain dot graph. So if you just specifically go to this kind of thing, then also you will get, there's a GitHub library, GitHub repository also. That this is also very good. Here we have a in library, we have, say the stars are 32.4K, right? In library, which is, you will get many resources from the internet. There are a lot many channels, there are a lot many freelancers who are explaining this framework, but the thing is you have to follow any one and start uh, working on those part. Understand step by step, don't get confused by having many resources. Only follow specific resource, first complete that, and then go to the next one, because every concept you have to learn it from the several different resources. It is the ocean of the knowledge. The concepts are having many aspects, so you have to learn it from the different aspects. Okay, right? So specifically, if you talk about any specific component, and if you are looking for, let's say you look at my code and you found that langgraph.graph, what it is, what kind of functionality is inside this, don't go to the start, don't go from the start, just try to learn this langchain.graph, what it is. Okay. So you will get many resources. Supposedly, if I just open this one only, then it here you will get all the details. Okay. Yeah. This GitHub repository is also very well. You will find this IBM repositories for the document. Geek for Geeks is also very good, right? It will tell you about everything in detail. Okay. So yeah, it is having many resources, but you should be able to understand from whichever resources you are able to digest the things, just follow that. Okay. So uh, this is langgraph.graph. So when we want to plot the graph, we have to use langgraph.graph. As simple as that. One line. If you want to plot a graph, or if you want to make a graph, if you want to compile a graph, if you want to invoke a graph, first is making a graph, then compilation of graph, and then execution. Execution means invoke. Invoke. So all these procedures, when you are doing for a graph, you have to use langchain.graph. Okay, and since we are using states for maintaining the in between information, like 5 plus 6 is equal to 11, that state will travel to the next node. 11 into 2 22, that will travel to the third node. Since we are using states, so that is why this has been made by LangGraph as state graph. Okay, this is the start node, this is the end node. In between, whatever logics are there, that you have to make. So start and end are the part of graph and are the dummy nodes. Okay, so there is no, it's like a pseudo nodes. There is no contribution of this in programming. This is just a start when the graph starts and when it is end. Okay. Now next is, let's say I want to calculate the BMI of the person. Okay. Now how to calculate the BMI? So this is very simple flow. You have to just understand the logic. For calculating the BMI, what sort of input you need to have, that you have to first think in your mind. You need weight, you need height, And then from this weight and height, you will get the BMI. That's it. Okay. Once you know that I need two inputs and one output, directly define inside the class which is inheriting the type date, because this is my state. This is called as definition of state. This is the first and foremost procedure that you need to follow when you start working with the line graph. You have to define the state. Okay, so you first have to think, what will be my class name? Class name is BMI state. That is your customized name. What it will be inheriting? Since I told you that states are always defined in type dict, because I want structured output, I will use type dict, because I will make this out. I will be having this kind of output. So my model will give this kind of output, where I will be giving the weight in the input, I will giving the height in the input, and I will get the output in my BMI variable. So this weight is float, can be float, height may be float, and BMI can also be float. Just forget about category for a time being. Okay. Now, once you define this, then you have to directly go for a drawing a graph. Don't go for in-between procedure. I'm giving you a workflow, like how you should think as an individual when you work with the line graph. When you have to first.
Sorry for interrupting, sir. Actually, our closing time is near.
Okay.
So we can take a couple of questions and then we'll resume tomorrow from here. Is it okay?
Okay. Okay. No issue. No issue.
Sure,
No
sure.
issue.
Yeah. So from the chat, you can pick some questions. Participants are requested to ask questions, if any. Thank you so much, sir, for the insightful session once again.
Thank you, sir. Thank you.
Dr. Sangeeta has some questions. Ma'am, please unmute yourself and you can ask now. You are panelist, ma'am. You can ask the question.
Yes, go ahead with your questions if you have.
Okay, participants can raise your hands. We will make you panelists and then you will be able to ask the questions.
I will share the link of GitHub. Where tomorrow we will start with proper programming. So at the same time, I will share the link. Don't worry. So kindly let me know if the flow, the speed is proper. If you want me to increase the speed of the teaching or anything.
Sangeeta ma'am, you can try now. You are anyway panelist, so you can you will be able to unmute. Dr. Ashwini Kumar, you can ask the question. Meanwhile.
See, N10, I am not taking intentionally in between. I wanted to give you the idea with very practicality by looking at the blocks. That is why I am taking N10. And LangChain, we are not bypassing. LangChain, we are already keeping. In this flow also, first, when I use the model, I use the LangChain for a grok, LangChain grok I have used. Okay, LangChain underscore grok, from which I imported the chat grok model. Okay, so LangChain we cannot bypass. LangChain is always there. Yeah, you have to make a git ignore file, .git ignore, and inside this you just write .env. So when you push to the GitHub, this env file will not get pushed to the GitHub. You have to make one .git ignore in your project folder, and inside that you just write .env. So whatever things which are there inside .env, like your API keys, will not be pushed onto the GitHub. I will share the link tomorrow. When we have already started with the workflow, so tomorrow I will share the link, and then you can fork it or maybe clone it. Okay. But these are the very small things which are very much important. Like if you don't know typed, if I talk about agentic AI, I don't need to explain you typed it, because which is a very basic concept of LangChain and generative AI. But since many of the participants from the different background, I'm taking the concepts in that sense so that everybody should be able to understand.
Okay, thank you so much, sir, for the wonderful session one more time. And we'll resume tomorrow, right? Participants can ask their question tomorrow also. So we conclude the day for now. And once sir shares the slides, I will post it in via email also, and also on the WhatsApp groups. Thank you. Thank you all.
Thank you all. Thank you.